In this lecture and the next few lectures, we're going to be talking about a popular type of vulnerabilities called SQL injections. Before we start talking about how this occurs and how to exploit it, let's first learn what SQL is. Now, if you're getting a pen test on a certain website, chances are this website is a little bit bigger than smaller websites, so it's probably using a database. Most websites, other than very simple websites, use databases, and the databases are used to store data. So they store usernames, passwords, news articles, blog posts, pictures, anything that happens on the website literally is stored on a database, and the web application queries the database and then displays the data to you or to the users on screen. When the users do something, it will either update, delete, or modify the data that exists in the database. This interaction between the web application and the database happens using a language called SQL. So let me show you what I mean by a database. This is just an example. I'm not hacking anything. I'm literally just going to log in to the database that is installed on our Metasploitable machine, and then we're just going to see what's being stored on it. So I'm not doing any hacking. There's nothing here, nothing fancy, just logging into my SQL, and then I'm putting the username as root, and the Metasploitable doesn't use a password for the root, which is really bad, but obviously it's a vulnerable system. So I'm just going to log in, and I'm not hacking anything. I'm not doing any SQL injections. This is just the terminal for my SQL, which the web application would use to interact with the database. So I'm just trying to show you what I mean by databases and what's saved in there. So the first thing I'm going to do is I'm just going to type in show databases, and that will show us the databases that exist on our target server. And we can see that we have the information schema. This is a default database that holds default information about all the other databases. So this one gets installed by default when you install MySQL. The rest have been installed for each web application. So we can see we have one for TikiWiki, we have one for OWASP 10, and that's for this one, Metal-Day. We also have one called MySQL, we have one called Metasploit, and one for DVWA, which is the one that we've been using, the web application. So you can see for each web application, we actually have a database, and this database holds the information that is used by that web application. Let me show you what's in there. So I'm going to use the OWASP 10 database. So this is the one that is, again, this is the one for Metal-Day for this web application. And we can see the tables. So each database has a tables, and in the tables there's information. So I'm going to say show tables to see the tables that we have. And you can see we have a table for accounts. So you can assume that this table has information about the usernames, passwords, and information about the users. We have a table for blogs, so probably has the blog inputs, the posts, and the comments in there. You can see captured data, credit cards. So there's a table that contains credit cards. Now this is huge for shopping websites. They actually would have credit cards table, and the information for the credit cards would be stored there. Basically, the database will store everything, all the data that is used on the website, because they don't get stored on files. It's not efficient. So let's have a look on the accounts. And if I just say select, so this is exactly how the web application would be retrieving information from the database. It will be selecting stuff, updating, or deleting. So I'm doing a select statement here. Again, this is not hacking. I'm not doing anything, just selecting stuff. And I'm going to select star, which means everything from accounts. Apostrophe. And as we can see, we have the account ID, the username, the password, and then the signature for the person, and if that person is an admin. Now, these columns depend on the table, so it's actually the person who designs the database, designs the tables, the columns as well, and then the data gets inserted by the web application. So we can see that we have a user called admin, and their password is admin pass. We can see we have a user called Adrian, and their password is some password. So this is just to show you what databases look like and just to get a feel on it, because in the future videos, we're going to try to exploit these databases and have access similar to this. So this, I just logged in with a username and a password now. Usually you wouldn't have access like this. Only the web admin would have that access. In the future videos, we're going to try to run some attacks in order to gain access similar to this, so that we'll have full control over the database, so that we can read stuff and see if we can write or modify things. So I just want to highlight why SQL injections are so important and so dangerous. The reason behind that is they are found, you can find them everywhere. A lot of places, a lot of big websites have these kind of exploits. And like things like Yahoo, Google had them. They're very hard to protect against, and it's very easy to make a mistake to make these exploits available for exploitation. The other reason that they're very dangerous is that they give you access to the database. In many scenarios, if you find an SQL injection, you really don't need to upload a PHP shell or get a reverse connection. There is really no point of uploading stuff and then increasing the danger of being caught. Because if you have access to the database, as we see in here, you pretty much have everything you need. You have usernames, passwords. You can log in with normal username and a password as a normal user. Or you can, if you're looking for sensitive data, we can see that we've had access to credit cards. You pretty much can do anything you want. So there's really no point of trying to further exploit the system. If you found an SQL injection, bingo, like that's all you need really. In many scenarios, we actually use a PHP shell to gain access to the database and see if we can read it. Like say, for example, if you manage to upload a PHP shell on this server, the Metasploitable, but then you couldn't access the database. There isn't much that you can see. You can't see credit cards. You can't see username and passwords. You really can't. Yeah, you have control over the server, but you can't read stuff. So sometimes when you upload a PHP shell, the next step is I need to gain access to the database. Another thing is that they can be used to do many things. So if you manage to find an SQL injection in a website that is not your target, so it's not the one that you're targeting, but it's in the same server, then you can use it to read files outside the www root, so similar to file inclusion vulnerabilities. You can use the admin, the username and password for the admin, and see if you can upload stuff. Usually the admin can upload a lot of things instead of just images, and then you can upload a PHP shell or a backdoor from there, and then from there navigate to your target computer, or to the target website, sorry. Or you can actually, in some cases, you can use it to upload a PHP shell. You can use an SQL injection to upload a PHP shell. So basically, SQL injections can be used as file inclusion vulnerabilities. They can be used as file upload vulnerabilities. And also, they'll give you access to the whole database. That's why they are very, very dangerous and very useful if you manage to find one. Now, to try and discover SQL injections, you need to browse through your target and try to break each page. So whenever you see a text box or a parameter on this form, for example, page.php, then something is equal to something, try to inject stuff here. So try to use a single quote, try to use an and, or the order by statement to break the page and make it look different. So I'm going to show you here an example. And I'm going to go into the login page first, right here. And it's asking me to log in. Now, I've actually registered with my own name, so you can just go in here and register. I have a username called Zaid and a password with 123456. So first, I'm going to log in just to show you. So my username is Zaid and my password is 123456. And now I'm logged in as Zaid and my signature was AA. It's just nothing really, just like as a test. So I'm going to log out and we're back at the login page. right here we have the page, so you can try to inject in that, but we'll get into that later. So at the moment we're having an example of injecting into text boxes. So you can try to inject into the name and into the password. So I'm gonna put my name as Zaid, and I'm gonna put a single quote. So I'm putting this sign into my password. So let's see if we can break it. And as you can see now, there is an error being displayed to us, and it doesn't look like a normal error. It looks like it's a database error. And usually you would be very lucky if you get an error like this. Now, usually the error won't be as informative as this. Sometimes you'll just see that the page is not acting as you expected. Sometimes it'll just be a page that does not look as it should. For example, if it's a news page, maybe it'll have the article missing, or if it's a blog, it'll have one of the posts missing, or different kind of posts. So you need to keep an eye on what's changing. In this example, we are actually getting a really nice error. It's telling us which file it has, and it's telling us that there's an error in the statement, and the error near the quotation mark that we added. And it also tells us the statement that's being executed. This is really good for learning, because now we can see what's the statement that the system is trying to run. And the system is trying to do a select star, so it's trying to select everything from accounts, where the username is equal to Zaid, and the password is equal to a single quote. And note that the system, the web application, is already adding quotes around the name. So when I said Zaid, it added Zaid between two quotes, and it added the single quote that I added between another two quotes. So that's why we had 3 quotes right here. So from this, it's like 70% that the target website has an SQL injection. We're still not sure if it can execute what we want it to do. So can I actually inject code and get it to be executed? Let's see if we can do that. So the username is going to be Zaid again. And what I'm going to do with the password, I'm going to put my password. So I'm going to put 1, 2, 3, 4, 5, 6. And then I'm closing it. So I'll tell you why I'm closing it, because the current statement in the system is it's select star from to Zaid and is equal to, and it's going to open a single quote by itself. So let's call this as password. So we're treating this as a variable, and it takes in whatever I put in here, whatever I'm going to put in this box, and it's going to insert it instead of the S password, which is a variable. So I'm giving you an idea. So you need to be able to imagine this happening. So it's taking whatever I put in there, and it's going to put it between 2 single quotes, and it's going to be inserted in there and executed on the system. So what I'm doing is I'm going to put 1, 2, 3, 4, 5, 6, and I'm going to add the quote myself. So what I'm going to do right now, the code is going to be like this. So it's going to select this, and password is equal to that. And I have 2 quotes right now. Okay. And then what I'm going to do is I'm going to say, and 1 is equal to 1. So 1 is equal to 1. And I'm just trying to see if it's going to execute what I want it to do. So my statement right now is it's going to be select star from accounts, where username is equal to Zaid and password is equal to 1, 2, 3, 4, 5, 6. And note, I'm going to be inserting this myself. And 1 is equal to 1. One problem that the system is going to complain about is that we have an extra quote here, because I'm going to be inserting this myself in the text box. So it's going to be complaining about this. It's going to say this is an open quote and it's has been closed. So what I'm going to do is I'm going to add a comment. And when you add a comment, basically everything that comes in after the comment will not be executed. I'm going to use the hash as the comment. So anything that comes in after the hash, the system is going to ignore. So what I'm going to inject now is going to be this, and 1 is equal to 1, and this. So as I said, usually what you have here, you have /$password, or depending on what the programmer called it, but we're just imagining this. And I'm going to be inserting this inside. So when you do that and you insert it inside, this is what the code is going to look like. So it's going to look like the right username, the right password, and 1 is equal to 1, which is true. And then it's going to ignore this quote right here. So if we paste this, we should be able to log in. It should allow me to log in. And perfect, we were able to log in, and username is Zaid. So far we haven't done anything, but this kind of shows us that is it running our code? Let's try a different thing now. Let's try to add a false statement. So what we did 1 equal 1, and that was correct, and it executed what we wanted. Let's try 1 equals 2, and this is false. So I have the right password, and I have the right username, but I added and 1 is equal to 2. And this should be wrong because it's false. 1 is not equal to 2, and I'm using an and, so everything has to be true. So it should give me an error, even though I'm going to put the right username, and I'm going to put the right password. So I'm putting 1, 2, 3, 4, 5, 6, and 1 is equal to 2. So it's going to be like, oh, this is wrong. And as you can see, it's giving me an authentication error, bad username or password, even though I'm given the right password and the right username. So this confirms that this website is actually injecting anything we want in the password. So we can use the password field to inject SQL code. And it's always going to be on this form. So we're going to put a password, and you're going to put your code here. So I'm just going to put it in capital code here, because we're going to put any password, close the quote, and then put the code that we want to execute on the system right here, and it's going to be executed on the target system. Okay, so now we know that we can put any code we want in here, and it's going to be executed on the system. So let's have another look now at the statement. So the statement says select star from accounts where username is equal to the username that we put here, and password is equal to the password that we put there. Let's see if we can use that to log in without using a password, without even knowing the password. And I'm going to be doing that with the admin. So with the admin, the username is going to be admin. And I don't know what the password is for the admin. So what I'm going to do, I'm just going to put anything. So nothing really, any random password. And in the code, what I should run here, we were doing and 1 is equal to 1 and or stuff. So what I'm going to do is I'm going to do or instead of and I'm going to say 1 is equal to 1. So what's our code is going to be? Once I run this, once I inject this, this is going to go in here like we were doing before. So our code is going to look like this. So it's going to be select star from accounts where username is equal to admin and password is equal to AAA. Now this is wrong. Or 1 is equal to 1, which is right. So anytime you have an or, if the or condition is right, everything is right. That's the way or statement works. So select star from accounts where username is equal to admin. Okay, username is equal to admin. And password is equal to AAA. That's wrong. Or 1 is equal to 1. Okay, I'll accept that. And then it's actually going to execute it and let us log into the admin without even knowing the password for the admin. So let's try to inject this now. And as you can see, I was able to log in as admin, and monkey is the signature for the admin. Now, bypassing logins can be done in so many ways, depending on the code that's written on the page and depending on the way you want to do it and how you're imagining the code. In a lot of the cases, when you put the single quote here, you won't see this message. Sometimes you do see it, which makes your job so much easier. If you don't, then you kind of need to guess what it looks like. So I'm going to show you another example of bypassing. Instead of injecting the code like this, the admin parameter is actually injectable as well. As you've seen when I put the single quote, the admin parameter is injectable exactly the same way as the password. So we can inject code in the username as well. And what I'm going to do now, so let's have a look on this. And I'm just going to reset it to the way it would usually look like. So you'd have, and the username and the password are the fields that whatever you put in here are going to be substituted in the username and the password. So let's try to inject something in the username. And what I'm going to say is I'm going to say username is equal to admin. and then I'm going to close the quote myself, and then I'm going to add a comment. So my statement, when I run this statement, it's going to look like this, and I'm actually just going to copy it here. And when I put this code in here in my name, it's going to inject that in there. So this is what the code is going to look like. It's going to select star from accounts where username is equal to admin. I close the quote myself here using this right there. And then I'm adding a comment. So basically all of this is not even going to be executed. So the code is going to be this. It's going to be select star from accounts where username is equal to admin. And it's going to let me log in without even entering anything in the password. So let's do this. I'm going to put my username as admin, and I close the quote and add a comment. And then you can put any password you want, really. I'm just going to put number 1, and I'm going to log in. And as you can see, I managed to log in as admin. So again, this is black box testing, so you don't really see the code. In many cases, you want to be playing around with it and see how it works with you. But the main thing is you want to test if the SQL injection exists, and you'd use that using the method we showed you in the previous video. So try a single quote, try the AND statement, try a true AND statement, so 1 is equal to 1, and then a false AND statement, so 1 is equal to 0 or 2 is equal to 0. And if they work as expected, then your target has an SQL injection and you can start playing around with it. Okay, now I'd like to show you an SQL injection in a different file, in a different page, and I'll show you a few different things that you can do to exploit that vulnerability. So the first thing, I'm going to go to the login page, which is in here, user info. So the first time we went to the login page, from there, this time we went to the user info page. So this page will show you the information about the user, provided you give the username and password. So I'm going to do Zaid, and I'm going to put my password 123456, and it'll show my details, username and password, and my signature is AAA. So the statement that's being executed here is similar to what was being executed when you log in. So it's selecting star from accounts, where username is what you put in the user field, and password is what you put in the password field. So what we're going to do now is we're going to see a different way of exploiting this kind of vulnerability. In the previous video, we were doing it using a post text box. So whatever you put in the text box was being posted using a post method to the web application. Now, these vulnerabilities can exist into GET. And what I mean by GET is when you do a GET, when something is sent as GET, you will see it here in the URL. So if you look at the URL here, you see it's being sent as the username Zaid and password 123456. So let me just copy this URL here. And we'll start playing with it from the URL instead of doing it on the web page. I just want to show you a different example because in many places, there might not even be text boxes. For example, it could be something like news and news.php. So we can see here, for example, in this example, it's index.php. And in your pen testing, you might see something like news.php. And for example, ID is equal to 2. And then you can try to inject stuff in there. So we're having an example here where we're going to be injecting things into the username field, which is this field. And we're going to be injecting stuff in here. So anytime when you're doing your pen test, anytime you see parameters like this, you should try to inject them. Anytime you see something.php and then you have a parameter equals something, then always try to inject stuff in there and see if it works for you. So we also seen a way of discovering the injection, and that was using the quotation mark and using the AND. So we do a false AND and a true AND 1 is equal to 1, and then AND 1 is equal to 2. And if the server is executing what we want, then we're going to know that there's an SQL injection. I'm going to show you another way of discovering these exploits, and it's using the order by. As the name suggests, the order by statement is used to order the results that we get on the screen based on a specific column. So our injection is going to be like this. So I'm going to do order by 1. So this, if the injection exists, this should work, because in each select statement there should be at least one column is being selected. Therefore, when we say order by 1, we're saying I want to order the results based on the first column. Therefore, this should always be acceptable by the database and return a true or something that we expect. We also need to add the comment in here and execute this code. So it's exactly like before. So when we're doing this, basically, this is our URL. And what's going to happen on the database, so this is the code that's being executed on the database, it's going to look like this. So it's going to be select star from accounts where username is equal to Zaid, and note how this is closing the quote, and we're going to do an order by 1, and there should be this code here for the end, and this comment will tell the SQL interpreter that to ignore anything that comes in after it, so all of this is going to be ignored. So I'm copying this. So you can actually paste this injection for Zaid order by 1 into the name right here, and that's going to work. But again, I just want to show you a different way of doing it by injecting it through the browser. Another thing that I want you to note is when you're injecting stuff into the browser, the code should be encoded. So for example, this sign usually, when you put it on the URL, it should be written as %23. Spaces, for example, get converted to %20, and %23 is the comment that we're using. So I'm going to copy that and replace my comment sign with it. Now you can Google HTTP encoder and you'll see online, there's online tools that will just convert this for you. For me now, I know that the hashtag can be converted to %23, so that's why I'm using it there. And I'm going to hit enter. And as you can see now, we're seeing something that's acceptable. Nothing wrong, and then it's showing me the information about Zaid 123456 and showing me the signature. So it is ignoring the password, so the injection worked, and it's ordering by 1, so it's not showing me anything wrong. Let's try to make this number 1 a very large number. So I'm putting 10,000 or 100,000 now. So what we're saying right now is I want you to order the results that will be returned by the current select statement based on column 100,000. Now, chances are there aren't 100,000 columns used in this select statement, and therefore this should return an error. So when I execute this, you'll see that there is an error, and the error is in the order clause, and it's telling us that there is an unknown column for 100,000. And this is great because now we know that the database is executing what we want. So when we told it to order the results based on the first column, it showed us results. So it followed what we told it. And then when we told it to order the results based on a column that does not exist, it gave us an error. So it's obviously vulnerable to SQL injections. Okay, so now let's try and determine how many columns are being selected into this page. So how much information are being selected and displayed on this page. So to do that, we're going to use the order by command. So we did order by 1, and that returned something that was acceptable, and order by 100,000 gave us an error. So let's try. Try and do order by 10, and we still get an error. So I'm going to do an order by 5, and that works. So let's try to do an order by 6, and that gives an error. So by doing this, we know that there is 5 columns are being selected from a certain table, and it's the accounts table, and displayed on this page. So let's try and build our own select statement and get it to be executed on the target computer. So let's come here and try to build it there. So at the moment, the statement is select star from accounts where your username is equal to Zaid, and we're doing an order by 1. So let's see if we can fix that and get it to select something that we like. So the normal way to select stuff is using this format. But because we're trying to do multiple selects and we're trying to do it from the URL, we're going to have to use a union first, and then we're going to say select. Then we need to imagine what's happening on this application. So in this web application, we know that there are 5 records being selected. So there are 5 columns that are being selected. So we're doing 1, 2, 3, 4, 5. And we got that from the order by command. So let's run this and see what happens. And I spelled union wrong. And as you can see now, the selection was right. And we got the first selection. So the first selection that this line does has been done. And then it did the union. So it combined that selection with another selection, and it showed us something else. And as you can see here, we're only seeing 2, 3, and 4. And what that means is whatever value you put in number 2 or 3 or 4, whatever you want to select, if you put it in there, it's going to be displayed in this page in this particular location. And you can see that here you have results for 2. So whatever you put in 2 will also be shown in here. So let's try to see our database. So instead of number 2, I'm going to say database. And instead of number 3, I'm going to say username or user. And instead of number 4, I'm going to do version. And this will select the current database, the current user privileges that we have, and the version of the database. So let's see if this gets executed, and then we'll talk about it. Okay, cool. So the username is showing up as OWASP10, and that was number 2. So that is the database that we're looking for. So the database is OWASP10. The current user that we're logged in as is root at localhost. So we're the root user. And in the signature, these stuff actually don't mean anything. We're only concerned about this and what we injected. And we injected the version, and we can see this is the version of MySQL. So it's 5.0.51. So at the moment, we know that our database that we're connected to is OWASP10. Usually, in most real-life scenarios, each database is assigned to a certain user. So usually, you're only able to select stuff, tables, columns, data that is located in this current database. At the moment, we're logged in as root. So this web application has been connected to the database as root. So therefore, we can actually access other databases, but this doesn't really happen in real life scenarios. Usually, each user has their own database. So when they connect a web application to a database, they connect it to one database, and therefore you won't be able to access other databases. So we're going to consider that. We're going to assume that we only have access to OWASP10, which is our current database for this current website. And then the username is root at localhost. In the next videos, we'll see how we can further exploit this and do more powerful select statements. Okay, so now we know our target database is called OWASP10. Let's try and discover the tables that exist in that database. So this is our select statement. It's a union select 1, and we have these things. So I'm going to leave this or change these to null, because I only want to select one thing now, and I'm going to set this to null as well. And in number 2, we're going to select table name from. Now we're going to select this from a database called information schema. Now I said this in the first video of SQL that information schema is a default database created by MySQL, and it contains information about all other databases. So what we're doing now, we're selecting the table name from information schema dot, and after the dot you put the table. So basically we're selecting a table called tables from a database called information schema, and the column that we're selecting is called table name. So we're selecting table name from the database that's called information schema from the table tables. Let's execute this and see if we can get all the tables that exist in OWASP 10 database. So we can see we got 237 records, and you can see all the tables that we have. So these are all the tables that we have access to. So again, I said we are logged in as root, therefore we can actually see tables from other web applications such as the TikiWiki, but in real life scenarios, you'll only see tables related to your current database, which is Matilda. So what I'm going to do is I'm going to use a where clause, and I'm gonna say where the table schema is equal to OWASP 10. So OWASP 10 was what we got when we selected the database. So we got OWASP 10, which is our current database that Matilda is working on. So we are using the same statement. We're selecting the table name from information schema tables, where the table schema is OWASP 10. So I'm going to copy that and execute it here. And as you can see now, we have so much less tables, and we only have the ones that we're interested in. So we have the accounts, the blogs, capture data, credit cards, hit log, and the pentest tools. Now, if you remember in the first or the second video in the SQL injection videos, I showed you what's the content of the OWASP table was, and it was these tables of the OWASP database. Now let's see if we can select and have a look on all the accounts that exist within this table. So let's see if we can query the database and read the information stored in the accounts table. To do that, we're going to first need to know the column names of the columns that exist within this table. Because if you look at the way we're using our statement, we're doing union select column name from a table. So we still don't know what columns exist in accounts. Now we can try and guess that there is a username and a password, but sometimes they could be different names. So I'm going to show you how you can select the columns for a certain table. The command is going to be very similar to the tables command. And the only difference is instead of table name, we're going to say column name. And instead of selecting it from the information schema.tables, we're going to select it from information schema.columns. And we're going to say where the table name is equal to accounts, because we're interested into the accounts table. If you wanted to get columns for another table, then you just substitute this with the table or with the column with the table that you want. So our command is going to be union select one column name from the information schema.columns, where the table name is the table that we're interested in, which is the accounts. And this should show us all the columns that exist within the accounts table. So let's run this command. And perfect. Same columns that we've seen before, and it's CID, username, password, my signature, and is admin. Now let's take this one step further and select the usernames and passwords from the account table. So again, the command is going to be very similar to what we're running at the moment. We're going to be selecting, and we're going to select username, and I'm going to select the password for number 2, and for number 3 we're going to select the is admin. Now remember, I can't select anything instead of number 1 and number 5 because they're never displayed for me on screen. The only thing that I see was number 2, 3, and 4, which were displayed here, 2, 3, and 4. So therefore, I'm only substituting values for 2, 3, and 4. And we're going to select that from accounts. And we're not going to need the where, so I'm going to delete the where. So very simple statement. We're selecting username, password, is admin from the accounts. And this should return all the usernames and passwords that exist within the current table, that exist in the accounts table. And I have an extra quote here that I'm going to delete. And as you can see, we got all the usernames and passwords. We have the admin, and their password is admin pass. We have other users, and we have their passwords, and it's also telling us whether they are admins or not. This is very useful because in most websites, when you log in as admin, you have so much more privileges than a normal person, and then you'd be able to upload PHP shells or backdoors, viruses, whatever you want to do really, and then further exploit the system. So at the moment, I can actually log in with a username admin and a password admin pass, and it's going to accept that because it's correct. So no matter how complicated the password was, we're just going to be able to read it because we're reading it straight from the database. In this lecture, I'd like to show you how we can use SQL injections to read any file in the server. So even if the file exists outside the www root, we'll be able to read it exactly like a file disclosure vulnerability. And we'll also see how we can use it to write files and upload them to the system, just like a file upload vulnerability. So the first thing we're going to have a look at is the reading the file. And I'm going to set everything to null here. So I have my statement here, and I'm going to set select 1. I'm going to leave number 2 because I'm going to do stuff in that. And we're going to do another 3 nulls here. So null, null, null. So we have select null, something, null, null, null. So 5 because we have 5 records when we did the order by. And instead of selecting something, remember in the third video we did select database, for example, and it showed us the current database. What I want to do now is I want to do another function, and that function is called load file. And in here, I'm going to set the file that I want to load, and I'm going to use the same file that we had a look on in the file inclusion vulnerability, and it was etc password. So we're trying to read that file, and our statement is union select that file, and that's it. So I'm going to copy this, and I'm going to inject it here, and I'm going to add my %23, which is my comment. And as you can see, we managed to read all the information, all the content of etc password, even though it's not in the web root, so it's stored in etc password. So we can read anything in the server from other websites, from other files, anywhere in the server we can read it by specifying the full path of that file. The next thing I'd like to show you is writing to the server. So we're actually going to write stuff to the server, and this is very useful because you'd be able to write any code you want. So for example, you can write the code for a PHP script, you can write a code for a shell, a virus, or a PHP code to get a reverse connection to you. So it'll basically just act like a file upload vulnerability. And to do that, I'm going to write the code that I want to do here, and I'm going to call that, for example, just example. And we're going to use a function called outFile. So we're going to do into outFile, and then we're going to specify where we want to store that file. Now, in best case scenarios, you'd be able to write to your web root, and that will mean that you can access the file through the browser and execute it. So you can upload a Weebly file and then connect to it and do stuff like that. So let's try to do that first. So we're going to do it in var www, and that's our web root, so we'll be able to access things through it. Or you can put it even var www and then put tilde after it to store it in there. So the command is very simple. Again, union select, make sure you set everything to null so that nothing gets written to the file except what you put in here. And I put example, and it's going to be stored into a file in var www tilde, and we'll call that example.txt. Let's try to run this and see if it works. Now this didn't work, and if you come down here, you'll see that SQL or MySQL is not allowed to create or write to this directory. So the problem is the permissions that we have don't allow us to write to this particular location. So just to test this exploit, I'm going to change this location to TMP, which is the temp. And you'll see that you can actually write to temp. So in real life scenarios, it depends. You can try it and see if you're able to write stuff or not. In this, we're trying to write to temp now. And if we read in temp, if we clear that, and then ls in temp, you'll see that we have something called example. And if we try to read that, you'll see that it contains the content of what we did before, which was the normal selection that you'd see. So what you see for putting the stuff for admin, and then it showed us what's in there, which is example, which is what we wanted to write to the file. Now you can obviously get rid of the admin and the admin pass stuff by just putting a wrong username, and nothing is going to be displayed here. So the only thing that you'll see is the output, which is example. But again, this is only useful if you're able to write to your web server, so you can access it and then use your shell or use your payload and further exploit the system. In all of the lectures so far, we were exploiting SQL injections manually. So we were injecting the code into the URL or into the text boxes. In this video, I'm going to show you a tool called SQLmap, which allows you to do everything we learned so far and even more stuff. This tool can be used against MySQL databases, which the one that we were having the example on. It can also be used against Microsoft SQL, Oracle, and other database types. The tool is very useful and is very handy in many cases. Sometimes the injections aren't as nice as the one we see, and sometimes you only get one output for each record and you have to loop through all the outputs. So the tool can automate that and just do everything for you much easier and much simpler. So let's first of all get the URL that we were using for the injection. So I have that text file here that we were using, and I have the URL that we were using before. So it's the userinfo.php, username is admin, password admin pass. You don't really need to know the username and password, so I'm actually just going to put anything here. So just to assume that we don't know the password. So we're only injecting SQL injections. We don't really need to know any of this stuff. All I'm going to do is copy this And then I'm going to run SQLmap. And I'm going to do U to specify the URL. And I'll put my target. And I'm going to make sure that I have it between 2 quotation marks so that it doesn't ignore anything in any signs in the middle. So we have some signs and characters in the middle that I wanted to all be treated as one URL. So all I did is SQLmap U my target. And I'm going to hit enter. And the tool will automatically look through all the parameters. So it's going to look through the user info, through the username and the password to see if any of them is injectable. And then once it does that, it's going to store it in its memory. So it's going to know that this is injectable, and then we'll be able to further exploit the target. So as you can see now, it's thinking that our target could be MySQL or PostgreSQL. It's asking me if it should skip other tests, and I'm going to say yes, because I know it's MySQL. And now it's asking me if it should do all the tests for both databases, and I'm going to say yes, assuming that I'm not sure which one it is. I know it's MySQL, but I'm just going to let it do its thing, and we'll see if it can do it properly or not. So at the moment, it's checking if it's PostgreSQL, and I'm assuming it's going to know that it's not, and then it's going to know that it's MySQL. It just found out that the username seems to be injectable. And sure enough, it's telling us here that the parameter username is vulnerable and we can inject it. So it's asking me, do I want to check the other parameters, such as the password and all of them? I can say yes and let it do it, but I'm going to say no, because I don't mind if it just uses the username for the injection, so it's all good. Now SQLmap knows that the target is injectable, and it knows that it's going to use the username parameter to inject stuff. And we can see that it figured out that it's running Linux Ubuntu, and it figured out that it's using PHP with Apache 2.2.8, and it's using MySQL server as the database server. So let's run SQLmap help and see what we can do now. Now, this tool is really big and it allows you to do a lot of things. So in this video, I'm actually just going to show you a quick look on the video, and I recommend you spend more time with it and try to see what else you can do with it. Okay, so let's try to get the current user, and we're going to try to get the current database. So we're going to use the same command that we used before, and I'm just going to add to it dbms to get the current databases, or dbs, sorry. As you can see, we got all the database that we have. So we have dvwa, we have information schema, Metasploit, MySQL, OWASP10, which was the one that we were exploiting before, and TikiWiki. Now, if we do current user, you can see that we are root. And if I do current database, we'll see that OWASP10 is our current database. So now let's try to get the tables for OWASP10. So remember when we did a select table name from information schema.tables, where table name, where table schema is equal to OWASP10. We're going to let SQLmap do all of that for us. And so the command is going to be, we're going to ask it to get all the tables for us. And we're going to use the D option to specify the database. And our database is going to be called OWASP10. And as you can see, it got us all the tables that exist. And remember, it's the same. We got accounts, blogs table, and the credit card as well. And now if we want to get the columns, then we can use the same command again. And we're going to say, get me the columns, where the table is called accounts and the database is OWASP10. And right here we can see that we got the columns. So we have the isadmin, the password, and the username. And we can get the data using the dump option. So it's the same command that we used before. So we're getting from the table that's called accounts and the database that is called OWASP10. I want you to get me all the data. And here we go. We got all the data. We have the admin, its password admin pass. And we have Adrian, and his password is some password. And we got all the data right here. So as I said, the tool is very useful. It can be used to make our life much easier. And it does everything automatically. And it can do everything we did. And it can even do more stuff. As you've seen so far, SQL injections are very dangerous. And also, they're very easy to occur and very easy to find. You'll find them everywhere in some really famous websites. People try to prevent these vulnerabilities using filters. Filters can make it look like there is no exploits, but if you actually try harder by using encoding, different types of encoding, or using a proxy, then you'll be able to bypass most of these filters. Some programmers use a blacklist. So for example, they prevent the use of union, they prevent the use of insert and stuff like that. Again, it's not 100% secure. It can be bypassed. Using a whitelist, exactly the same issues as the blacklist. The best way to do it is to program your web application in a way that it does not allow code to be injected into it and then executed. So the best way to do that is to use parameterized statements where the data and the code is separated. And the best way to show you what I mean by that is using an example. I'm keeping the least amount of programming in this example. I don't want it to be a programming example. There's actually mistakes in the programming in there, but I'm trying to give you the concept more than how to program it. So the vulnerable code that we were looking at used to do this. So it used to do select star from accounts where username is equal to whatever we put in text box 1. And then we used to put in text box 1. Let's just put it here. We used to say admin and then close the quote. And then we're able to do a union, select, and execute something else. And then once we're done, we used to add the comment, which basically ignores everything that comes in after it. So when you copy this and you paste it in here, you'll see what's happening. So it's selecting. Now let's just get rid of this because this is just making the colors not nice. Now I'm actually going to just put a comment on this. So it's going to do a select star from accounts where username is equal to admin, union select, and execute whatever we want to do. This is very bad and it's very hard to protect against. As I said, using filters and stuff will only hide the problem, will not fix it. The best way to do this is using the parameterized statements just like so. So this is the safe way to do it. First of all, you prepare your statement. Most languages like PHP and all of them, they actually have a function like that. And you can prepare select star from accounts where username is equal to question mark. And then you send the values. So PHP now knows the SQL statement is select star from accounts where username is equal to something. And then it's going to take the value of text box 1. So even if we come in and we use our very sneaky statement right here and paste it in there, the web application will know that the value for this is admin union select. So it'll actually try to go and select star from accounts where the username, and then it'll add its own quotes and it try to find a username with the following username. So this whole thing will be executed like so. So it will be select star from accounts where username is equal to admin union select this hashtag. So it'll never, whatever you put in your text box will be sent as a value, and the web application will know that this is a value, it's not a code, and it'll never execute it. Therefore, this will protect you against SQL injections. You can use the filters as second line of defense, and I also advise that you use the least privileges possible. So use for each database, use one user with the least amount of privileges they want. So don't allow the users to do anything that they want. Allow them, if it's a simple website that only does selection, then only allow the user to select. If it only needs to select and insert, then only allow them to select and insert. And this is a rule you should keep with everything, even with Linux systems. Make sure the permissions are always as least as possible. Each user don't have any extra permissions that they don't need.